Hello dear students. Today we are going to discuss the second topic from the chapter Units and Measurement of +1 Physics. Here we will discuss about the topics accuracy, precision and errors. Okay. So first of all we can say about accuracy. It's a common word that we are using, accuracy. Okay. This is nothing but it is the measurement of how close the measured value is with the true value. Suppose we are having a true value, we are having some measurement which is the true value of that measurement. Suppose length of a table whose true value is 7.5 centimeters, sorry 75 centimeters. Okay. The exact value or true value is 75 centimeters. When we are measuring this with some scale or some other instruments and we are getting a value of 74.2 for me and one of my friend who did the same experiment with same measuring instrument and he got the value 75.2. I have got the value 74.2 and he got the value 75.2. But the exact value is 75. Then we will check whose value is much more closer to the true value. Then that is considered as, or those value which is having less deviation from the true value, which is considered as more accurate reading. Okay. So this is simply the term accuracy that we are now, this is a common term that you are using, and this is nothing but this is how close the measured value with the true value, that is the measurement of that closeness is referred as accuracy. Okay. Now we can see the next term, precision. Precision means up to what extent you can measure that value. How many decimal places are there? If more decimal places are using, then you can say that simply, this is the most simplest way to explain, which is more precise. So the same thing, we can see some example over here. The true value of measurement is 7.55 and two persons are measuring this value or this thing with some measuring instrument, and first one got the value 7.4 and second person got the value 7.32. Exact values or true value 7.255, but one person measured it and he got the value 7.4 and the second person measured it, he got the value 7.32. Okay. So in those two readings, that in two measurements, 7.4 is more close to this exact value 7.55 compared to 7.32. Then you can say that first measurement is more accurate than second one because the closeness is more in the case of first reading. But when you are looking at the precision, you can say in the case of first measurement we are using some instrument whose least count is only 0.1. That means we can measure the value 7.4, then he can measure only the value 7.5, not any value in between them, that is 7.41 or 7.42, 7.43, nothing he can read. He can read only up to 7.4, then 7.5. The values intermediate between them is not, he cannot measure those values. So his scale will give only the values 7, 7.1, 7.2, 7.3, 7.4, 7.5 and so on. But in the case of second measurement or the person who is using some other instrument whose least count is 0.01, in that case he can measure the value 7.41, 7.42, 7.43 etc. Here he got the value 7.32. That means his reading is having the least count which is 0.01 and which is the more precise value compared to the first case. Okay. The first case only we can have the values, we can have the difference only 0.1, 0.2, 0.3 etc. But in the second case, the device is having the difference 0.01, 0.02, 0.03, etc. So that means the second device is more precise than the first one, or the second measurement is more precise than the first one. So precision depends upon the least count of the instrument. Least count means which is the smallest value with which an instrument, the smallest value that can measured with an instrument. Okay. So if you are using a device, measuring device whose least count is having more decimal places, that is 0.01, 0.001, 0.003, as if there are more decimal places, that shows that it is more precise. Okay. That is the difference between accuracy and precision. Here look at the example once again. 7.55 is the true value, and first person measured it as 7.4 and second person measured it as 7.32. Because the first person can read only 7.1, 7.2, 7.3, 7.4, and then he can read only 7.5, nothing in between them. So he got the value 7.4. But this is more closer compared to the second value, hence you can say that this is the accurate value compared to the other one. And but in the case of second measurement, he can read the values 2 decimals after the point, decimal point. Okay, 7.31, 7.32, 7.33, etc. So his measurement is more precise compared to the first one. Okay. Now the term errors. As we have already mentioned, accuracy is the close, how close it is. Error means what is the difference between the measured value and the true value. The difference between true value and measured value will given as, or will be known as, errors. This also we are using this term error, which is a common term, which is nothing but which is the measurement of difference, or how the measured value is differing from the true value. That difference is referred as errors. These errors can be classified into different types, that is systematic errors, random errors, and least count errors. Systematic errors means these are again classified into 3 types: instrumental errors, procedural errors, and personal errors. These are simple terms. Instrumental error means this is the error because of the problem with the instrument that we are using to measure. Wear and tear of the scale, some other problems, such problems with the measuring instrument, that results in some errors. That type of errors are known as instrumental errors. Second category is procedural errors. Procedural errors is also nothing but it is the error in the procedure itself. Such type of errors are referred as procedural errors. Third one, personal errors. Personal errors because of the carelessness of the person who is taking the readings or measurements. So the carelessness of person who is taking the readings results in some type of errors. Such type of errors are referred as personal errors. These 3, instrumental errors, procedural errors, and personal errors, these 3 are belonging to the category systematic errors. And the second category or second type of error is random errors. This is nothing but these are the errors arise due to unpredictable situations. Something like fluctuations in voltages or the environmental conditions. All these things may affect our observations or readings, measurements. Such type of errors is referred as random errors. We cannot control over this. That depends upon the fluctuation of current, or because depends upon the environmental conditions. That sudden change in environmental condition may result in some errors. Such type of errors are referred as random errors. Now the third category, least count errors. Least count errors are nothing but these are the errors because of the incapability of the instrument, whose least count may not sufficient to get the exact reading. Suppose we are measuring a reading of 2.35 centimeters, 2.35 centimeters. But if you are using an instrument whose least count is only 0.1, then you cannot read that 3.5, you can read only 2.3, then the next reading will be 2.4. That is because of the least count problem. We are using some device whose least count is not sufficient to give the exact value. The errors arise due to such conditions is known as least count errors. These are the major types of errors. Now we can see how you can calculate errors, different types of errors that we are just mentioned: systematic errors, random errors and least count errors. Now the measurement of these things, calculation of errors. To find the errors, first of all we are taking several readings and you have to find mean or average of all these values. The average, or you can find the mean by just using the relation A is equal to A1 plus A2 plus etc. An divided by n, where A1, A2 etc. An are the measured values at different times. So we are measuring 3 times, then A1, A2, A3. The measured values are A1, A2, A3. By 3, if you are dividing it with number of measurements, then you will get the mean value, or which is taken as the average value. Okay. Now if you want to calculate absolute error, you have to take the difference between this average value with the corresponding measured value. Take the difference between the average value or mean value with the measured value, but not that we have to take only the magnitude, not the sign. That is, you have to take only the positive values only. There is no need of negative values. Okay, that is the absolute error. If you are finding mean of all these absolute errors, that is referred as mean absolute errors. If you are finding the mean of all these absolute errors, then you can say that this is the mean absolute error. Okay, that is delta A1 plus delta A2 plus delta A3 plus etc. delta An. Which here delta A1, delta A2, delta A3, all these are absolute errors of this corresponding measurements. If there are n measurements, you are adding all these absolute errors and divide by number of observation. That will give you the mean absolute error. Okay. Now the term relative error. Relative error is nothing but it is the ratio between mean absolute error with the mean value. Ratio between mean absolute error with the mean value is simply the relative error. If it is expressed in percentage, then it is known as percentage error. The expressions are given: delta A bar, which is the mean absolute error, divided by A bar, which is the mean value. Then that ratio delta A bar by A bar is known as relative error. If it is multiplied with 100, then it is represented in percentage. That is the percentage error. Now the next term, combination of errors. Here we are performing different operations: addition, subtraction, multiplication, division, then exponent functions. In such types of measurements, there are some methods to get the net error of that particular experiment. So that is referred as combination of errors. In the first case, you can check how you can find the error in sum or difference of readings. Look at that. If delta A and delta B are errors in A and B, we are making some measurement. So you got A plus or minus delta A and B plus or minus delta B. The first measurement is A plus or minus delta A, where A is the main value and delta A will be its error. Here in the second case, B plus or minus delta B, where delta B is the error in the measurement of A and B. If you are finding A plus B or A minus B, you have to add the corresponding absolute errors or mean absolute errors. So the error of the result that of A plus B or A minus B is equal to delta A plus delta B. That is the error part in the result. In the result, the error part will be delta A plus delta B. Here we have given an example: L is equal to 3.2 plus or minus 0.2. Here 3.2 is the true value and 0.2 will be its error. b is equal to 2 plus 0.1 centimeter. So, here 2 is the true value and 0.1 is the error. So, here delta A is equivalent to 0.2 and delta B is equal to 0.1. Then if you are finding L plus B, then the error of the product of the result is not the product, error of the result is delta L plus delta B, that is 0.2 plus 0.3 which is 0.3, 0.2 plus 0.1 which is 0.3. Even if you are measuring this L minus B, if you are measuring L minus B, here in that case also the error is sum of the absolute errors, that is delta L plus delta B is again 0.3. Whether it is addition L plus B or is L minus B, there is no difference in the case of measuring the total error of the result. It will be the sum of individual errors. Okay. If you are considering the case of product or quotient, if you are measuring a value and you are finding the product of that two measurements, or if you are calculating the quotient of or division of two measurements, then in that case we will take the relative error of the particular measurement and then you have to add that. That is, in the case of the result, the total error will be, total relative error will be the relative error of first measurement plus relative error of second measurement, even if you are multiplying two measurements or even if you are dividing two measurements. That is, look at this example, x is equal to a plus or minus a, delta a, where delta a is the error. Here in the second measurement delta B is the error. Then the relative error of measurement x is delta x by x, which is the relative error of measurement of x, that is nothing but delta A by A. Similarly, relative error of measurement in y is delta y by y, delta y by y, which is nothing but delta B by B. So, if you are multiplying x with y or dividing x with y, in both cases the product or the result will have an error, relative error, which is equal to delta A by A plus delta B by B. Okay. So, this is the method of finding relative error. In the case of product or quotient, you are finding sum of relative errors of the corresponding quantities, that will be the relative error of the result. Okay. Now, if you are considering the term exponent terms, then also you are finding the relative error of each measurement. In that case, if x raised to a, where a is the power of measured value x, then the relative error in x is delta x by x is nothing but, not relative error, the relative error of the product is delta x by x into a, that is the power into relative error of x plus the power into relative error of y, that will be the result of the measurement z, or that will be the error in the measurement of z. So, z is equal to x raised to a by y raised to b, here a is the exponent. So, a into relative error of x, here it is an operation division. In the case of in the previous case we have mentioned that if we are using multiplication or division, you have to add the relative errors of each and every measurement, that is why the additional term here, and y raised to b is there, then power of second measurement is b and into relative error of y. This will be the error in power or exponent terms. Okay, so these are the main contents that we are going to, that we have discussed. That is nothing but accuracy, precision and errors, and how you can calculate or what are the combination of errors. All these things that we have discussed just now, and we will do the previous year NEET problems in the next session. Thank you.